In this video, we are going to find the extreme values of f of x comma y equals x squared plus y squared plus 4x minus 4y on the region described by x squared plus y squared is less than or equal to 9. Okay, to do this, we're going to want to use the method of Lagrange multipliers. So what is that? This is basically a method that will allow us to find the maximum and minimum values of f. So what does it say? It says to find the maximum and minimum values of a function, let's say f of x, y, z, subject to a constraint. So let's say subject to the constraint g of x, y, z equals k. And again, this is assuming that these extreme values exist and that the gradient of g is non-zero on the surface g of x, y, z equals k. Okay, so how do we find the maximum and minimum values? Well, step 1 says find all values x, y, z, and lambda, or find all values of x, y, z, and lambda. Such that the gradient of f of x, y, z is equal to lambda times the gradient of g of x, y, z, and g of x, y, z is equal to k. That's step 1. Now what's step 2? Well, for step 2, we want to evaluate f at all of these points. So evaluate f, x, y, z at all the points x, y, z from step 1. And once we evaluate them, we'll have certain values. So the largest of these values is going to be the maximum of f. And the smallest of these values is the minimum of f. Okay, so maybe this doesn't make a lot of sense right now, but we're going to try to follow these steps to solve the problem we initially started with. So first, we want to compute the values of f at the critical points in the region x squared plus y squared is less than or equal to 9, with extreme values of f on the boundary of x squared plus y squared is less than or equal to 9. So this is just coming from the above, right? So we have this constraint where we're given this region x squared plus y squared is less than or equal to 9. So first, we want to find the gradient of f, which means that we want to find the partial derivatives of f with respect to x and y. So I'm going to scroll all the way down here and rewrite f Okay, so what is the partial derivative of f with respect to x? So that would be the derivative of x squared. That's 2x. Then we have y squared, so we can treat y like a constant, so that's 0, plus now the derivative of 4x with respect to x, that's just 4. And then we are subtracting 4y, which again, there's no x there, so we can treat that as a constant. Great. And now we also want to find the derivative with respect to y. So the derivative of x squared would be 0, y squared would be 2y, 4x would be 0, and minus 4y would be minus 4. Now we want to set these equal to 0 and see what we get for x and y. So if we set fx equal to 0, so 2x plus 4 equals 0, we solve for x, we get 2x equals negative 4, divide both sides by 2, we get x equals negative 2. Now if we do the same for fy, 2y minus 4 equals 0, we add 4 to both sides, we get 2y equals 4. Now divide both sides by 2, we get y equals 2. Great, so what does this tell me? This tells me that we have the point 2, 2, which this point, notice it lies in the region x squared plus y squared is less than or equal to 9. We can check this just by plugging in the point. So minus 2 squared plus 2 squared is 4 plus 4, which is 8, and that's certainly less than or equal to 9. So this is an interior critical point, is what this tells us. Great. Now we're not done yet. We want to see what points we can find on the boundary. The boundary being this g of xy. So let's define that. So we have x squared plus y squared is less than or equal to 9. So this g of xy will be x squared plus y squared minus 9. And now we want to find the gradient of this. So the partial derivative with respect to x is just the derivative of x squared plus y squared minus 9 with respect to x, so that'll just be 2x. And then the partial derivative of g with respect to y is just 2y. Now, what do we do from here? Well, step 1 of the method of Lagrange multipliers tells us that we want to find all values of x, y, z, and lambda such that the gradient of f equals lambda times the gradient of g. So that's exactly what we're going to do now. So we have that. I'll write that down. We want to check this, or find all x, y, z such that this is true. Now we can first do this for x. So the derivative of f with respect to x should equal lambda times the derivative of g with respect to x. So what is that? Well, for fx, we got 2x plus 4. So this is telling me that 2x plus 4 equals lambda times gx, which is 2x. Okay, now I want to solve for lambda. So I'm going to subtract lambda 2x from both sides and subtract 4 from both sides. So now this becomes 2x minus lambda times 2x equals minus 4. Now I can factor out a 2x to get 2x times 1 minus lambda equals minus 4. I can also divide both sides by 2 to get x times 1 minus lambda equals negative 2. Now I can do the same for fy equals lambda times gy. So for fy, what did we get? We got 2y minus 4. And for gy, we got 2y. So this should be equal to lambda times 2y. Now we're solving for lambda, so I'm going to subtract lambda times 2y from both sides and add 4 to both sides. So we get 2y minus lambda times 2y equals 4. So I'm going to factor out a 2y. We get 2y times 1 minus lambda equals 4. Now I can divide both sides by 2. So this becomes y times 1 minus lambda equals 2. Okay, great. So what does this mean? Well, if 1 minus lambda is not equal to 0, then from here we can get values of x and y. So what happens for x? This becomes x equals negative 2 over 1 minus lambda. So x would be negative 2 over 1 minus lambda. And then what would y be? Y would be 2 over 1 minus lambda. Okay, great. And so we know that this has to be on the boundary. The boundary is x squared plus y squared equals 9. So what does this give me? I'm just going to square x, which is minus 2 over 1 minus lambda, and I'm going to add it to y squared, which is 2 over 1 minus lambda squared, and this should equal 9. So here I have 4 over 1 minus lambda squared plus 4 over 1 minus lambda squared equals 9. So this tells me that 8 over 1 minus lambda squared equals 9. Now, I'm kind of solving for lambda, what 1 minus lambda is. So I'm going to multiply both sides by 1 minus lambda squared and divide both sides by 9. So maybe I'll do that in 2 steps. So this is 8 equals 9 times 1 minus lambda squared, and then divide both sides by 9. Okay, now I can take the square root of both sides. And so I'm going to continue over here. So if I take the square root of both sides, I get 1 minus lambda equals plus or minus the square root of 8 over 9. So I can write this as plus or minus 2 root 2 over 3. And so now that I know 1 minus lambda is this, I can get values for x and y. Now we have 2 different solutions. 1 minus lambda can be positive 2 root 2 over 3 or negative 2 root 2 over 3. So we'll have to take both into account. So first, let's suppose that 1 minus lambda is equal to 2 root 2 over 3. Then what do I get for values of x and y? Well, x is equal to negative 2 over 1 minus lambda, so negative 2 over 2 root 2 over 3. So this is negative 2 divided by 2 root 2 over 3, which is the same as multiplying by the reciprocal, so times 3 over 2 root 2, and we see these 2's cancel out. So this is equal to negative 3 over root 2. Now what do I get for y? Well, y is 2 over 1 minus lambda, so 2 over 2 root 2 divided by 3. Again, that's equal to 2 times the reciprocal, so that's this. 2's cancel out, so I get that y is 3 over root 2. So if 1 minus lambda is 2 root 2 over 3, that gives me the point minus 3 root 2, comma 3 over root 2. Okay, now what if 1 minus lambda is equal to negative 2 root 2 over 3? What do we get for x and y? Well, again, x is negative 2 over 1 minus lambda, so this would be negative 2 over negative 2 root 2 over 3. So this is negative 2 times the reciprocal, which is 3 over negative 2 root 2. And so these negative 2's cancel out. And I'm left with 3 over root 2. What is y? Y is 2 over 1 minus lambda, which is minus 2 root 2 over 3. So it's 2 times 3 over minus 2 root 2. So the 2's cancel out, but I'm left with a negative sign. So this is minus 3 over root 2. So what does this give me? This gives me the point 3 over root 2, comma, minus 3 over root 2. Great. So what have we done so far? We've basically done step 1 of the method of Lagrange multipliers. We found the values of x and y such that the gradient of f equals lambda times the gradient of g. So what are the 3 points we got? Well, we got an interior point. We got this point negative 2 comma 2. And then on the boundary, we just did all this work and we got the point minus 3 over root 2 comma 3 over root 2 and 3 over root 2 comma minus 3 over root 2. So what part 2 of the method of Lagrange multipliers tells us is we have to evaluate f at all 3 points and see which gives us the largest value and the smallest value. And that'll tell us what the maximum and minimum of f are. So let's write this down. We want to evaluate f at the points minus 2 comma 2, minus 3 over root 2, comma 3 over root 2, and 3 over root 2, comma minus 3 over root 2. So let's start evaluating. Recall that f of x comma y was this function x squared plus y squared plus 4x minus 4y. So what is f of minus 2 comma 2? That's going to be minus 2 squared plus 2 squared plus 4 times minus 2 minus 4 times 2. So this is 4 plus 4 minus 8 minus 8. So this is minus 8. Okay, now we want to plug in, let's say, negative 3 over root 2, comma 3 over root 2. So this will look a bit messier, but let's see what we get. So we have minus 3 over root 2 squared plus 3 over root 2 squared plus 4 times minus 3 over root 2 minus 4 times 3 over root 2. Now here comes the fun part, which is simplifying. So for the first squared term, we get 9 over 2 plus also 9 over 2. Then we have minus 12 over root 2 minus 12 over root 2. So what is this? So we have 9 minus 24 over root 2. Now this looks pretty ugly, so what we can do to this fraction is multiply by root 2 over root 2. And what do we get? We get 9 minus 24 root 2 over 2. So this simplifies to 9 minus 12 root 2. And that's a lot nicer. Okay, great. Now we still have to evaluate f at one more point. We want to evaluate f at 3 over root 2, comma minus 3 over root 2. So this is going to be 3 over root 2 squared plus minus 3 over root 2 squared plus 4 times 3 over root 2 minus 4 times minus 3 over root 2. So similarly, we get 9 halves plus 9 halves. This time we get plus 12 over root 2. Now we have negative 4 times negative 3 over root 2, so that's also going to be plus 12 over root 2. So we get 9 plus 24 over root 2. Again, that looks pretty ugly, so I'm going to multiply that fraction by root 2 over root 2. Again, why can we do this? This is essentially just multiplying by 1. I mean, it is multiplying by 1. We're just writing 1 as root 2 over 2. So we're not changing the value. So this becomes 9 plus 24 root 2 over 2, which is 9 plus 12 root 2. Okay, great. So let's do a recap. We got that f of minus 2 comma 2 equals negative 8. F of minus 3 over root 2 comma 3 over root 2 equals 9 minus 12 root 2. And then we got that f of 3 over root 2 comma minus 3 over root 2 equals 9 plus 12 root 2. So you can use a calculator to get approximations for the second and third values, since it might not be immediately obvious what they are. So the second one, 9 minus 12 root 2, is approximately minus 7.97. And then 9 plus 12 root 2 is approximately 25.97. Okay, so what did part 2 of the method of Lagrange multipliers tell us? It tells us that the largest one of these values is the max of f. So here we see 25.97 is the largest value from minus 8, minus 7.97, and 25.97. So we have that f max equals 9 plus 12 root 2, and that happens at the point 3 root 2 comma minus 3 root 2. Now from minus 8, minus 7.97, and 25.97, which is the smallest value, well, we have minus 8 is the smallest, so that tells me that f min is minus 8, and that occurs at the point minus 2 comma 2. And so that's pretty much it. We found the extreme values of the function f of x comma y on the region described by the x squared plus y squared is less than or equal to 9. If this video is helpful, feel free to like and subscribe.